how did space shape the story of our planet? We'll learn more this week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. When we think about the environment, we often picture Earth, its oceans, forests, and blue skies. But historian Dagomar Degroot argues that our environment extends far beyond our planet. His new book, called Ripples on the Cosmic Ocean, explores how events across our solar system, from Martian dust storms to solar flares, have transformed life and history on Earth. We'll talk about what he calls cosmic environmental history, and why understanding our place in the wider system may help us protect our world today. Then, Planetary Society Director of Government Relations, Jack Corelli, joins me for a quick update on the political turbulence surrounding NASA leadership and the Artemis program. And we'll wrap things up, as always, with Bruce Betts, our chief scientist, for What's Up. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. Our relationship with space isn't limited to exploration, rockets, and telescopes. The worlds around us have been shaping life on Earth for billions of years. That includes everything from our sun to small asteroids. Historian Dr. Dagomar Degroot argues that understanding these cosmic influences is key to understanding our own planet's past, present, and future. His new book, Ripples on the Cosmic Ocean, An Environmental History of Our Place in the Solar System, was published by Harvard University Press on October 28, 2025. It invites us to see the solar system as an interconnected ecosystem, one that has always shaped life on Earth. Dagomar traces how solar cycles, Venus's runaway greenhouse effect, Martian dust storms, and even Cold War fears of nuclear winter have influenced human civilization. From the asteroid that ended the dinosaurs to the science that helped us save the ozone layer, he shows how events in space have shaped our planet and the story of humanity. Dr. Dagomar Degroot is a professor of environmental history at Georgetown University and holds the Baruch S. Blumberg Chair in Astrobiology, Exploration, and Scientific Innovation at the Library of Congress. He's also the host of a podcast called The Climate Chronicles, where he explores the history of climate and civilization. I spoke with him about what he calls cosmic environmental history, and why looking outward may be one of the best ways to protect our world and our people. Hey, Dagomar, thanks for joining me.
Oh, it's such a pleasure. Thank you for having me.
I had a wonderful time reading this book. As part of this job, I have the privilege of being sent many, many space books, but I think there's a lot that we can learn from the study of environmental history here on Earth. But you've taken a really interesting tactic here in that you've expanded out this idea of what our environment is to include all the worlds around us. Can you define what environmental history is and why you made the decision to extend that beyond Earth to include our cosmic environment?
Absolutely. So environmental history can be defined in a bunch of different ways. I like to define it as the study of the reciprocal relationships between humanity and everything else in the universe. And that can range from single-celled organisms to galaxies. It's kind of revisionary. History as a discipline, when it was professionalized in the 19th century, was all about, great men and how their ideas and decisions influenced the past. And really for the 20th century, historians have tried to argue, different groups of historians, that more and more people had an influence on humanity's past, right? From blue-collar workers to women to non-white men, right? The list keeps growing. And eventually in the 60s and the 70s, a group of people said, humans don't just create their own past by themselves. We are part of environments, we're part of nature. And, not only have our decisions, our history, not only has that shaped the natural world, but also the natural world has changed in ways that must have influenced us. So that gave rise then to the study of environmental history. And the study of environmental history has been Earth-focused. It's been about everything from earthquakes to soils to you name it, but it's all focused on Earth. And you could say, these environments that we focused on have been living and non-living. So for me, I've been an amateur astronomer since I was a kid. That's why I've listened to your podcast for many years. Right? I've just been passionate about amateur astronomy. So I feel like, maybe I had the insight, maybe I knew that, there's stuff that happens beyond Earth as well. Really important things, the sun is changing. There's constant flows of energy and even matter through the solar system. And I felt like, well, if we're going to think about the non-human Earth and its influence on humanity's past, we ought to think about environments in a much bigger way too. We can start thinking about how the solar system is a collection of environments, and even dynamic environments that have changed. So from that idea came Ripples on the Cosmic Ocean.
I did note that as I was reading your book, there are these beautiful little moments where you're talking about the kind of revelations that you have when you're outside with your telescope. So I love that you've woven in your own personal journey with astronomy and those moments into the book as well.
Thank you. That was actually really important for me. And it's a little bit different, I think, from a normal history book, right? Or from a normal, it's a quasi-academic book, I guess. But academic books usually are kind of, not first person, right? But for me, not only the motivation of the book, but also kind of the passion behind the book, and even kind of an important part of my life. When I look at the cosmos here from downtown Washington, D.C., I feel like I'm connecting with something much bigger than myself, of course. It's almost a spiritual kind of experience. And it connects me also to many, many people in the past, right, who looked up at the night sky and saw its changes and responded to those changes, sometimes in ways that made history. So it's helped to make me a better historian, I think, doing this kind of stargazing. It's also given me the passion that you need, I think, to write a book. And it's really, made me, I think, a different kind of person than I would otherwise be.
Well, that context allows you to see something that other people might not have, right? To actually take the step back and look at the ways that humanity has been impacted by space over time. I think it's really easy to think about, well, not necessarily easy as it is a more modern field of history, but it's easy to think of the ways that humanity has been changed by our local environment. But unless you actually contextualize that with the things that change that outside of us, it's a very different perspective to say humanity has been altered by famines or ice ages versus solar activity drove systems on Earth that then led to human war and famines and broader systems. That's a very interesting way of thinking about it. And it's one more way of connecting ourselves to the space around us.
Yeah, I think so. And it took the book actually in a very unanticipated direction. I thought when I started the book years ago, I thought I was going to write something that helps contextualize what I viewed and still view as kind of a new space age, right? Where you've got these space companies like SpaceX, Blue Origin, but also new space agencies and newly capable space agencies, all pushing out in different ways and beginning to realize those dreams of the 1960s, right? Of space exploitation, maybe, space settlement, different ways of actually using space and maybe eventually living in space for human beings. But as I started to write the book, I began to realize, these environmental changes that happen in space and that have influenced our past kind of also make us precarious in a way that scholars have realized now, I guess, and written about for decades and centuries. And in fact, many of our ideas about risks to all of humanity, which we call existential risks, they've come to us through space exploration. So the book took on a different character. It began to consider these kinds of profound existential risks to humanity and how we began to realize those risks through space exploration, space discovery, and in some cases, even how we were able to mitigate or begin mitigating some of these risks, again, as a result of what we do in space. So in a way, the book is also an argument for the importance of outer space research, space science, including astrobiology in human affairs.
Well, you named this book Ripples on the Cosmic Ocean. which clearly I'm going to love. It's a reference to our co-founder, Carl Sagan, who said that the surface of the Earth is the shore of the cosmic ocean. Why did you choose that name for this book? And how has Carl Sagan impacted your work more broadly?
Oh, so I chose, I think, the name for the book. Well, I knew about Carl Sagan when I was a kid. I grew up in a tiny little town called Wainfleet. And actually an even tinier part of that town called Winger. And this is a place with about 300 people. And my goodness, there was nothing to do. And I just remember growing up, obviously it's before the internet, because I'm getting older, before the internet. And I just remember dreaming of things that were far away. That's how I got interested in history, actually, because I kept imagining times far removed from my time when exciting things happened. And that's also then how I got interested in outer space, because I kept thinking about what was happening elsewhere, as far away from Winger as possible, is what I cared about. So in getting interested in outer space, I visited libraries and I checked out books, which is what we did back in those days. When we were interested in something, we checked out books instead of going on social media. And of course, that's how I encountered the work of Carl Sagan. I read Cosmos cover to cover multiple times, and eventually, as I got older, also was introduced to some of his other work, including Pale Blue Dot, which I reference in the beginning of Ripples on the Cosmic Ocean. So I'm sure that somewhere in my brain, I had this idea of the cosmic ocean, and that came from Carl Sagan. But also, when I got started in environmental history, I was actually a historian of oceans on Earth and climate change. And one of the things I did in my early career was argue that natural climate changes before human-caused global warming profoundly altered the oceans and changed how wind especially moved over the oceans. And that then actually altered how people could live on the oceans, how they could move across the oceans, which had an impact on economic history and military history hundreds of years ago. This comes up a little bit in Ripples on the Cosmic Ocean, but that's actually how I started my career. So the ocean was very, very much, I think, in my mind as I started working on Ripples on the Cosmic Ocean, which at first did have a different name. But then I guess gradually this early Sagan influence and my own continuing work on oceans got me to change the title to something maybe that's a little bit more evocative.
Mm-hmm. What are the ripples in this context?
Yeah, the ripples are the environmental changes, or what I would call the environmental changes in cosmic environments. Everything from, explosions on the sun to dust storms on Mars, to radio signals coming from Jupiter, and all the things that comets and asteroids do. All these things are disturbances, I would say, in cosmic environments. And the book is really about how these disturbances have influenced us, the last 500 years of human history. Also how people have imagined those disturbances, right? Even if they weren't real. And even in some cases recently, how we might have been making our own disturbances in outer space environments, our own changes, some of which we didn't realize, and some of which are now on the drawing board, like terraforming Mars.
Mm-hmm. Well, our understanding and our kind of interaction with the space environment kind of fundamentally changed around the 17th century. What was it that altered the way that humanity began to interface with the universe around us?
So the easy and the incorrect, I think, answer is that the telescope was invented. So the telescope was invented in probably around the first few years of the 17th century, though the origins are a little murky. And it allowed natural philosophers, as they were then called, to see things that they couldn't see before, from sunspots, right, to the rotation of Jupiter's moons around the planet, to craters on the moon, right? They could see these space environments. And it's a very beautiful thing, because it's almost like you create like this magical instrument. It's like magic, basically, right? You can start to see across the veil that surrounds you from and has long sort of hidden away the true nature of reality. Right? So it's this incredibly powerful, almost magical device that lets you see things that, hundreds of millions of people have never been able even to imagine. So it is really profound, the invention of the telescope. But it's not the whole story. And in fact, even the invention of the telescope comes from other things. There is the Reformation. That's like this huge schism in the church. And the Reformation allows for pockets to emerge in Europe where you can think freely and talk openly about the nature of reality. So that's really important. That happens in the 16th century. Of course, what also happens is the dawn of an era of a discovery of colonialism in the 15th century. There are literally new worlds, right, as they were called by Europeans, discovered on Earth. And new sciences, kind of new ways of knowing emerge around the discovery of those new worlds as people are trying to make sense of them, trying to understand them, and realizing that the Greeks and the Romans, in fact, did not know everything, right? and they didn't know about a lot of the stuff that's actually happening on Earth, right? So that prompted kind of new ideas that enabled challenges of old ideas or encouraged people to combine ideas in different ways. So there's all this kind of upheaval. The 16th and the 17th centuries in Europe, at least, are really about upheaval. It's a jarring time to be alive. And it's also the kind of time that encourages and permits new ways of understanding the universe, right? Obviously, you've got this kind of change from an Earth-centered way of understanding the universe now increasingly to a sun-centered way of doing so, the Copernican revolution, which slowly unfolds over like a century or even longer. You've got the development of gravity, the theory of gravity, and you might call it the scientific revolution, sort of takes hold halfway through the 17th century. So there's all these, and it's really complicated, all these entangled changes in culture, in economics, even in politics, that come together in just the right way to enable the invention of the telescope, and then really the foundations of modern astronomy. And I would say also new conduits between environmental changes in outer space and human history on Earth.
Well, in this book, you break down each environment as we go, starting with the sun, which clearly is the place that we should start. I mean, other than just what's going on here on Earth, the sun is one of the greatest dictators of our local climate. But it's interesting because you highlight that there are larger celestial cycles, the Milankovitch cycle, solar variability, axial tilts, and each of these influence the climate. But how do these forces all combine to shape larger systems like ice ages or ultimately human migration and civilization?
That's a great question. And I have to plug something. If your listeners are interested in this, I've started a kind of multimedia thing that I call the Climate Chronicles. So they can look through and really dive into some of these changes. It's like an audiobook. But the big thing to know about Earth's climate over the past 40 to 50 million years is that we sit at the tail end of a prolonged cooling trend. And that cooling trend probably began with the collision of the Indian plate into the Eurasian plate, which pushed up the Himalayas and through precipitation began scraping carbon dioxide out of the atmosphere. That was kind of the initial push. And then from that comes just an enormous and dramatic cooling trend, unfolds again for tens of millions of years. And by the time you get to about 2.5 million years ago, the Earth is probably cold enough for regular cycles in its rotation, so the wobble of its rotation and the tilt of its rotation, and cycles in the ellipticity of its orbit around the sun, to begin overlapping in ways that can actually reduce temperatures in some seasons in some parts of the Earth. And that begins to enable what we call then ice ages, and what are more appropriately called glacial periods. Right? So then you start getting these alternating glacial periods and interglacial periods. But interrupting those periods are actually dramatic pulses of cooling or warming, which are caused by the shutdown and resumption of circulation systems in Earth's oceans. So it's a mess. It's a real big climatic mess. And in that mess, we evolve. And perhaps we evolve our big brains in part because they allowed us to adapt to all of these changes unfolding around us. So this is a period now that's called the Pleistocene, a period of these constant climatic swings, cooling and warming. And it's only about 11,700 years ago that things stabilize, get a little warmer. It's really just an interglacial period, and that we then develop agriculture. Different groups around the world develop agriculture, all in a relatively warm, stable, and wet climate, which we call the Holocene. So that's kind of the big climate picture in about 30 seconds. But you can look at more at the Climate Chronicles.
And I'll include a link for that on the webpage for this episode of Planetary Radio so people can check it out.
Awesome.
But before reading this book, I'd never really internalized that the sun was such a driving force behind human conflict and even bigotry in some instances. It's kind of easy to think of famines and ice ages as these local events, but if we take that step back and really think about how they're driven by these larger factors, and then those things led to human migration and war, and in some cases, blaming of marginalized groups. It's this larger cycle, and that gives a whole different flavor to human history for me.
I'm happy to hear that. Yeah, so if you think about the Holocene, so that's 11,700 years. Globally, temperatures are relatively stable, but regionally, things could still change quite a bit. And even small changes globally of several tenths of a degree Celsius could have a big impact on pre-industrial communities, which in many cases were much more sensitive to shifts in weather than we are now. Now, I should emphasize, you're talking about these changes of several tenths of a degree Celsius. The Earth has now warmed by 1.5 degrees Celsius since the late 19th century as a result of human greenhouse gas emissions. So we are changing the climate much more than it has ever changed in the Holocene, and in a way bringing us back to the chaos of the Pleistocene years that we were lucky to survive. In any case, those small changes in the Holocene do seem to have had, a profound impact on human history. They in some cases reduced harvests dramatically, causing famines, widespread starvation, political destabilization, rebellion, wars between countries. So especially then in a period that we call the Little Ice Age, from about the 13th century to the 19th century, when cooling really came in waves driven by, in part, maybe changes in solar activity, but also by these spectacular, explosive volcanic eruptions that release sulfur dioxide into the stratosphere. So a Little Ice Age is a period where there's waves of cooling. They're relatively small compared to modern warming. But as you say, they definitely had an impact on human history.
You also trace how our understanding of the sun has been shaped through science, from Herschel and his early sunspot studies to things like the Carrington event. What would you say are the biggest lessons we can take from these solar events that are probably most urgent for us to address these days?
Yeah. So the one thing I'll say about Herschel and his solar discoveries, and kind of a finding I had while working on this book that really struck me, is that William Herschel, so he's this astronomer in the late 18th century, discoverer of the planet that he called George, that was later renamed Uranus, right? So he really laid the foundations for a lot of climate research today, because he used his telescopes to chart changes in the number of sunspots on the sun, which got him to think that, well, if the sun is changing its appearance, Earth's climate must be changing as well. And that got him to do research into the history of grain yields, and to kind of try and reconstruct, as we call it, reconstruct climate changes in the past, and to figure out the ways in which those climate changes might have influenced human affairs. So William Herschel, I think, is one of the unheralded founders of climate science. And how did he discover it? Well, it's by observing the sun and its changes. In terms of solar storms, so coronal mass ejections and solar flares, the biggest lesson I think we should learn from that is that we might be at risk, right? Solar storms have influenced our history in some pretty profound ways, none more so than when a spectacular solar flare sent radio waves towards Earth that jammed radar stations, American radar stations, and seemed to reveal that a nuclear attack was underway, a Soviet nuclear attack. Just barely avoided total nuclear war, potentially human extinction, because solar forecasters were able to warn NORAD, so American officers, that in fact, this was a solar storm, not a Soviet jamming effort. So huge impacts in the past, potentially really catastrophic impacts in the past. But now, again, there's a lot of uncertainty about how profoundly a solar storm could influence us. There's been really interesting research using tree rings that seems to suggest that there were massive solar storms in the past, much bigger than those of today, those that we've experienced in recent centuries. But also there have been studies of sun-like stars across the galaxy, which may indicate that sun-like stars are capable of much bigger storms than we've experienced. So it's entirely possible that we are overdue for a megastorm, and we've just become more and more dependent on electrical systems and electrified systems, from satellite constellations, obviously, to AI, to even pipelines, which use electricity. Transmission lines are getting bigger as we shift to renewable power in many parts of the world. So it's, in some respects at least, an increasingly vulnerable world. And we should heed the lessons of the past to, first of all, continue to fund solar research and to experiment with things like AI systems for predicting solar storm events, and then, develop ways of protecting our electrical grid, which is the key vulnerability, I think, to solar storms.
It's so interesting that the sun sparked all of these new ideas in science that allowed us to create this technology that is now made vulnerable by the thing that led to its invention in the first place. That's just
exactly.
Really interesting. But after the sun, you take us into the history of Venusian exploration and how that shaped our understanding of Earth and life in the universe, but also climate change more broadly. How would you say that Venus played a role in specifically humans' understanding of climate change, not just here on Earth, but on worlds all across our solar system?
Well, Venus was thought to be a temperate world in the late 19th century. And one of the great shocks of the early space age in the 1950s was the discovery of evidence, the accumulation of evidence that Venus was in fact the hottest world in the solar system, and probably the world you would least like to be on. It was a hellscape, right? Fascinating hellscape, but a hellscape nonetheless. As long as you were on the surface of Venus, the cloud tops of Venus are considerably better, but you do not want to be on the surface of Venus. So how did Venus, which is a planet that is in some respects so similar to Earth, right? It's about the same size as Earth. It's made of about the same stuff. It's relatively close to Earth, technically on the inner edge of the habitable zone around our sun. How did Venus come to be so very different from Earth? That was one of the great mysteries then also of the early space age. And of course, Carl Sagan helped to solve that mystery by developing models and the ideas that there could have been a runaway greenhouse effect on Venus that created today's planet, that supercharged the temperatures on Venus. So if there was a runaway greenhouse effect on Venus, what did that say about the stability of Earth-like worlds, right? What did that say about Earth's future? This became a very urgent question after the confirmation in sometime between the 60s and the 80s that the world was warming, our world was warming. Human greenhouse gas emissions were beginning to raise global temperatures. And so Venus became a kind of worst case scenario in the 1980s, a kind of warning of what could befall the Earth if we continue to burn fossil fuels. And in fact, we've subsequently found, scientists, that if we were really ambitious and we decided to burn every last atom of fossil fuels on Earth, we probably would set in motion the same kind of runaway greenhouse effect that might have warmed Venus, because we would begin to boil the oceans, and water vapor is a greenhouse gas, so that would further warm the Earth and boil more of the oceans, and eventually maybe we turn out like Venus. So it is still a very effective warning.
What's interesting is that it doesn't just pose this existential threat, but if we look at it the other direction, it also suggests that we could enact some kind of positive climate change or some kind of alteration of other worlds' climate systems, which then ultimately leads to this idea of terraforming. So it's both terrifying, but also, suggests that someday it might be within our power not just to fix our planet, but potentially make other worlds more habitable.
Yeah, and in fact, you could argue that research into the atmosphere of Venus is why we are able to have this podcast right now, because research into chemical reactions in the atmosphere in the 1970s began to expose how the ozone layer could potentially break down. There is no ozone layer on Venus. Other strains of research confirmed that there was, in fact, a hole in Earth's ozone layer caused by CFCs, which were in like refrigerants and spray cans, and that hole was growing dramatically. And so in the 1980s, you get the Montreal Protocol, which limits the ability for companies to produce CFCs, and the hole stops growing. But if that research into Venus's atmosphere never happened, you might argue that either you wouldn't have had the Montreal Protocol, or you would have had it later when more damage is done. We now know that if the ozone hole had kept growing, there would have been just a tremendous wave of skin cancer all over the Earth. The DNA would have started to break down in plants and animals, so there would have been an even worse biodiversity crisis. And the ozone layer plays a big role in Earth's climate as well, so there could have been an intensification of global warming. It would have been potentially even apocalyptic were it not for the Montreal Protocol. So this is one of the good news stories in human history. It's evidence that we can actually do something about existential threats. And it's also one of the ultimate examples, I think, of space research benefiting life on Earth.
We'll be right back with the rest of my interview with Dagomar Degroot after this short break.
For over 45 years, members of the Planetary Society have teamed up to crowdfund science and technology projects like LightSail, the 100 Earths Project, PlanetVac, and so many more. The STEP grant program continues that concept but uses an open call for proposals to cast our net far and wide to find the best projects. The first 2 rounds of STEP grant winners have done great stuff, ranging all the way from developing a new technique for studying near-Earth asteroids to doing a careful comparison of different ways to grow edible plants in space. We're once again going to invite the brightest minds worldwide to discover the next breakthroughs in our 3rd round of grants, and we need your help. This vital scientific research will be made possible with your support. Right now, funding cuts at NASA and the National Science Foundation are threatening scientific research. There's never been a more urgent time to support independent scientific funding. This is real space science and technology funded by you. Donations given today will go directly to the next round of STEP grant winners. Please join us in this crucial endeavor by making a gift today at planetary.org/step. Thank you.
I don't remember how many years ago it was. I was speaking with Michelle Thaler, who was at the time in charge of NASA's communications. I think she was director of NASA communications at the time. And we were speaking about something. And I asked her whether or not, we could save the world from these broader things, climate, but also asteroids and things like that. And her answer to me was, we've already saved the world through science, specifically because of the ozone layer, and told me a bit more of this history and the dire consequences of what would have happened if we didn't have the Montreal Protocol. And I think people generally kind of joke about like, oh, that hole in the ozone layer. I don't think it's commonly known just how close we came to devastation and how much we should all be celebrating the fact that we managed to turn this around.
I could not agree more with that. Mm-hmm. And I think actually these stories are incredibly important to tell because, I'm a professor at Georgetown University and so I teach young people, and more young people are kind of hopeless about the future. They're worried about climate change. They're worried about nuclear war. They're worried about AI. And there's no end of things that seem scary right now. But the past shows us that it's possible to confront even these biggest of challenges. And if not to completely stop them in their tracks, then at least to reduce the risk. And, it's a story of science. It's a story of politicians sometimes taking risks, of companies sometimes even acting in the public interest, or at least finding ways to act in their own interests that don't harm the public. But it has been done before. So I think that's an uplifting story maybe for our young people.
And clearly humanity is capable of uniting to do wild things. After Venus, you go on to your chapter about the moon. And I mean, this dream of putting humans on the moon has so drastically altered recent human history. But even now, we're talking about returning humans to the moon and potentially sending humans to Mars. And that is a driving factor in how much funding we get for space. And I think we're in a really interesting time where there's this kind of discussion about whether or not we should be scaling back money for scientific exploration with robots and giving more money to things like human space exploration. And I think we should be able to walk and chew gum at the same time, right? Clearly, putting people on the moon has been a huge driver for both funding, but also human curiosity about space. But I don't know. It's an interesting situation we find ourselves in. And what are your thoughts?
Well, I'm a supporter of the Planetary Society in part because I passionately believe in space science and the value of space science. I would say that belief goes back to my childhood, but it certainly has been strengthened by writing Ripples on the Cosmic Ocean. The space science has had all kinds of profound beneficial impacts for life on Earth, and I think it is borderline suicidal to cut funding for space science, in part because, it's helped to identify so many of these risks, and others might be out there. So I agree with you 100%. I actually do support efforts to direct more funding to crewed space exploration, including to the moon and Mars. But at the same time, I do not support cutting space science at all. There is one thing that I've been wrestling with lately, which is the role of the astronaut and space exploration. And this is something I get into towards the end of Ripples on the Cosmic Ocean. But, we live in a time of rapid AI development, and it's now possible to imagine that artificially intelligent systems will be competent scientists on the moon or Mars, right? And they'll be able to do many of the things that astronauts can do there. I think we're kind of challenged to start thinking of what can humans uniquely do in space? And is space settlement something that we should be thinking of as an urgent priority? And there's a beauty and a romance in space settlement, I think, for me as well. There are arguments for it that I think are very interesting, like, humans being in space could have experiences that no humans could have on Earth. Human settlements in outer space could experiment with new forms of governance even, right, that might go on to benefit people on Earth. But I think we are still challenged to think of whether the costs of sending people to Mars, for example, rather than robots, which are probably in the hundreds of billions of dollars, maybe even the trillions, depending on what you tend to try and do there, if those costs are now worth it. Do we want to leave outer space to the machines? Or do we want to allow the machines to build things for us that we can then use? I think it's a really interesting moment where we're sort of challenged to think of what the human role in space should be, at least in the next few decades.
And it also brings up this need for more regulation and space law when we're thinking about these things, which you bring up throughout a lot of this book, but particularly when we're talking about, Mars and other human settlements. I don't think when people were laying down things like the Outer Space Treaty back in 1967 that they imagined how rapidly our technology would advance. They weren't thinking about things like asteroid mining or Mars tourism when they wrote those.
Yeah, well, it's interesting to think about what they were thinking about, right? And why their dreams might not have come to fruition in the 1960s. Because, of course, that was the first space age. I like to think of two space ages. So I like to think of the first space age maybe beginning in the 50s and sort of petering out into the 90s, and now us being in, legitimately a new space age. And I do actually think that a lot of what we now anticipate and the technologies we're now developing kind of take us back to those first years of the space age. The likes of Wernher von Braun or Korolev in the Soviet Union, they were expecting us to move on to Mars quickly after being done with the moon and to build space stations. They had a grand vision of human life in outer space, and they had an expectation that we would be developing space stations and space settlements into the 70s and the 80s. And if you had told them how things really turned out, they would have been crushingly disappointed. Mm-hmm. And in a sense, we are in a similar moment where you've got these technological systems, coming online, like hopefully Starship, and promising all of these breakthroughs, like dramatically reduced costs for getting stuff into outer space, that now seem to be finally materializing. But it's possible to imagine that progress peters out, right, in the future, if there's less interest in doing things in outer space, if there's a war on Earth, God forbid, right? So even now, I think the future in space may be more precarious than we expect. With that said, I think it is true that we have to start thinking more seriously about whether space environments need to be protected, whether there are environments on planets that are special, that deserve special respect, that need to be conserved. A classic example is the moon landing sites, the Apollo moon landing sites. But you could even argue that there are places on Mars that are more likely to have microbial life, and therefore astronauts should not go near those places. This is an argument that has been made for decades. Or perhaps we should be very careful about going into the cloud tops of Venus, right, where there's very controversial phosphine detections maybe, but there's been long discussion about the possibility for microbial life there. What about the ocean worlds, right, of the outer solar system? How should we engage with those places? So now is the time, I think, for very serious discussion of space conservation, and even you could call it space environmentalism, not when we're actually already sending human beings to Mars, let's say.
Well, I'm definitely seeing a rising interest in this, both for, planetary protection reasons, but also this idea of not polluting the space around us. I think images of things like back shells on Mars, for some people, are very inspiring. For others, lead to these ideas of we're just going to be spreading pollution around the solar system as we've done with our own world. So now is definitely the time to begin having these conversations, especially as our search for life continues.
I think that actually also gets us into an interesting point, which is, should the space environments have rights, let's say, that terrestrial environments do not, right? We litter terrestrial environments. We bring our microbes all over the place, right? Why should we be careful about avoiding forward contamination, so avoiding microbial contamination on Mars, let alone on the moon, which almost certainly has no possibilities for life? I would actually argue that one thing we should be thinking about for the future of space exploitation, space settlement, and exploration should be how to reduce humanity's burden on the Earth. Because I think terrestrial environments probably are uniquely important, valuable. They are, after all, teeming with life, and humanity for the foreseeable future will depend on them. So the kind of idea of offloading energy generation to space to the extent that's possible, or in the long run, offloading industry into outer space, and maybe even in the very long run, human numbers, human population. I think that's a very important idea, and I think that's one that I would probably support.
Well, we need to defend our world in multiple ways, right? It is the only world that we know has life on it. And it's very interesting to point out that we have all these concerns about planetary protection when it comes to other places. But it's really easy to just, throw your trash out the window if you're living here on Earth and not think about the consequences, right? But you also bring up comets and asteroids at the end of the book, and how this other existential threat of defending the Earth has altered human history. I've had a lot of conversations about these moments like Shoemaker Levy 9 and how that altered human history, but there's so much to be said there.
Mm-hmm. And this is another one of those good news stories, right? And it's a classical good news story where you have a plucky bunch of scientists, right? And they're laboring in the darkness for decades, and they're trying to track these asteroids that might pose a threat to Earth. So, Eugene and Carolyn Shoemaker are kind of the leaders in some of this work. And nobody takes them seriously. There's what they call the giggle factor, right? So no one actually expects that an asteroid or a comet could hit the Earth. And I think this is hugely important, and it gets right at the heart of what makes existential risks to human existence, so difficult to deal with. Because by definition, we've never experienced them. right? And so they seem like something out of a science fiction book, right? And there's a high giggle factor around them. And maybe more of us are taking the threat of AI seriously these days, but I think it's still kind of a niche idea that AI could bring about our destruction. More and more people are concerned about nuclear war, for example, but still, I don't think we would rank nuclear war as one of the most important things facing the United States right now. Same thing with climate change. I think a lot of people are concerned about it, but maybe the really apocalyptic stuff is still a fringe, right? You go down the list. Asteroids were the ultimate example of that in the 1980s. Something straight out of science fiction and never could impact us. And then a few things happened. And one of those things, as you say, was the Shoemaker-Levy 9 comet fragment impacts on Jupiter, which I still remember vividly. I was 9 years old, and I just remember all those flashes on astronomy magazines, the infrared flashes, and just being blown away by those impacts, like so many people were, right? Here was proof that a planet could be just wrecked by a relatively small comet. I mean, my goodness, this comet was, like, these comet fragments were not more than a kilometer or so across, right? And here you have the biggest planet in the solar system, and it looks like it just, got in a fight and came out worse for it, right? So that was really a critical threshold. But there were others too, and they pushed in different directions. I think that's something that really came out from my research for the asteroids and comets section of the book, is that there were things that were pushing people to take asteroid and comet impacts more seriously, and there were things that were pushing them away from that. So the end of the Cold War is something that pushed people away from what we might call impact mitigation, right? So you had all these weapon scientists who were suddenly out of a job, including ones who were working on the Strategic Defense Initiative or Star Wars, and they proposed these outlandish schemes to protect the Earth from asteroids and comets. That helped to discredit the whole enterprise. So it's always fascinating with history because there are so many different things pulling in different directions. But ultimately, the efforts by these plucky scientists started to get more and more funded. And ultimately, for a very modest amount of money, scientists were able to detect and track thousands and thousands of near-Earth asteroids. And that actually ended up dramatically reducing the risk, because risk is really all about perception, right? So by just cataloging an asteroid, tracking its orbit, and determining that it won't impact Earth, you end up reducing risk. Then, planetary defense becomes entrenched inside of NASA by Congress, and you've got these wonderful asteroid redirection impact missions like DART most recently. And, a kind of proof of concept that if we're able to detect an asteroid, we can see that it's spiraling towards Earth, and we have enough lead time, we can actually alter its orbit. So the risk of an asteroid impact goes from being unknown but potentially very serious in the 1980s to now being much better known and very, very, very low. And I think that's just a wonderful example of existential risk mitigation reduction.
There's so much left in this book that I wish we had time to speak of, but I'll leave that to the reader to get into it, to learn some more of this wonderful history. And I hope it recontextualizes the way they think about our world and our connection with all the other worlds around us. But before I let you go, after tracing 5 centuries, literally, of cosmic environmental history, what is the biggest takeaway that you hope readers carry from this book with them into conversations in real life?
Well, the biggest takeaway, and takes me back to Carl Sagan, that picture that is so central to the history of the Planetary Society and so central to how many of us think about outer space, right, which is the pale blue dot. And Carl Sagan described the pale blue dot with the most beautiful words that I think were ever written in connection to space exploration. But he mentions the dot as being alone, right? There's nothing around it. It's separated. There's no hope of relief from outside of the dot, which is probably true. Ripples on the Cosmic Ocean looks at the sunbeam that kind of cuts over the dot, right? And it argues that there's the vision that we see between Earth and the rest of the cosmos is in large part an illusion, right? Earth is, again, kind of a node in a much, much bigger set of environments. And that's partly why outer space research, exploration matters so much. So I hope readers come away with that realization.
Well, Ripples on the Cosmic Ocean, an environmental history of our place in the solar system is out now. Thank you so much for writing this book and for coming on the show and for being a fan of Planetary Radio. I think I just learned, just as much from you as maybe you've learned from me and our guests over the years. So
I sincerely doubt that. It's been a dream for me to come on your show for a long time. So thank you so much.
This book, as with so much of space exploration, makes me reflect on the fact that we are all part of something so much bigger. What happens in space never truly stays in space. But right now, the choices that we're making here on Earth are shaping the future of exploration beyond it. To bring us up to speed on what's happening at NASA and in Washington, D.C., I spoke with Jack Corelli, the Planetary Society's Director of Government Relations, for a quick space policy update. We'll speak about what's going on with the NASA administrator role and how that's impacting broader things at NASA, including the Artemis program. Hey, Jack.
Hi, Sarah.
I read recently that Jared Isaacman might be back in the running for NASA administrator. What's going on there?
Indeed, you are right. So yeah, even though the government is shut down, that doesn't mean politics isn't. The administration, of course, the president had nominated Jared Isaacman in December of last year before they took office, the earliest that a NASA administrator has ever been nominated, and then withdrew that nomination in May of this year. And in a very shocking turn of events that sort of coincided with the falling out between the president and SpaceX CEO Elon Musk. But Jared is back in the running to be NASA's administrator. NASA has gone with an acting administrator since January 20th. At first, it was Janet Petro, who was running the Kennedy Space Center. And then in July, was replaced with Secretary Sean Duffy, who is the Secretary of Transportation and former congressman from Wisconsin. And so since July, Secretary Duffy has been in charge of the agency. But as of recently, it's come out that Jared Isaacman has still been angling for the position. You can see if you follow him on social media, he's certainly aligned himself with the administration and their policy priorities as it relates to space and other topics. And he's interviewed with Secretary Duffy, who's taking an active role in finding his full-time replacement. And according to some of the same reports, has also met with the president on multiple occasions. And so this is historic, right? He was the first NASA administrator nominee to have his nomination revoked. And now he's trying to get the nomination back and get renominated, which has also never happened in the outside of instances where the nomination might go beyond the end of a Congress, where you do technically have to get renominated in the new Congress. This is the first time that it was withdrawn within the same session of Congress.
Is there a timeline by which we have to have this sorted out?
Yes. The Vacancies Act, the law that governs how long someone can be acting, the acting head of an agency, dictates 210 days is the limit that any person can fill as an acting head of an agency. And so Secretary Duffy began his tenure in July. I will note, according to the Vacancies Act, if a full-time replacement is nominated, that does reset that clock for another 210 days. And anytime any what they call nominating action takes place, so that could be a vote by the Senate committee, a confirmation hearing, anytime an official action is taken on that nomination by the U.S. Senate, that resets that 210-day clock. And so you could still see, I know Secretary Duffy has made, sort of comments, and the expectation is that he will be serving in that acting role through the end of calendar year 2025. It could go even further into 2026, just depending on the timeline for any nomination or renomination for a full-time NASA administrator. Now, one of the sort of interweaving, there's a couple other topics that have come up in the last week with the announcement of Jared's campaign to be renominated, which also has seen a groundswell of people supporting it as well, on social media in particular, that Secretary Duffy apparently had a conversation early on in his acting tenure, speaking to folks at the White House about potentially folding NASA into the Department of Transportation, which I will note just up front, if that has perked your interest, that's not going to happen overnight. That actually requires an act of Congress. And Congress is actually working on a piece of legislation that would probably be the vehicle for making such a change, called a NASA authorization. The latest draft of that does not have NASA be put under any other department or agency. NASA is what they call an independent agency of the federal government. It has been that since its founding in 1958. I will say the issue of putting NASA under another department or creating a new department that includes NASA is not a new one. Even dating back to the initial conversations within the Eisenhower administration in 1957 and 1958, after Sputnik, there were conversations about moving what was called NACA, NASA's predecessor organization within the federal government, moving NACA into another department, something that has gone through some different names, a Department of Science and Innovation or Department of Science and Technology. And that topic has come up time and time again over the years about whether it is beneficial to the agency, to the priorities of the agency, to put it under a larger department.
What would be the benefits or the drawbacks of moving NASA into a different department?
Well, the benefits are, we're seeing some of them right now, right? The benefit of being within another department that has a secretary, a cabinet level secretary in particular, right? Sean Duffy sits on the president's cabinet, is that NASA then gets a seat at the table, which typically, in previous administrations, the only time that NASA issues come up would be, in the event that there is a National Space Council, which we still have, that is chaired by the vice president, and the vice president, who also sits on the cabinet, mentions it. But we've only had National Space Council under a handful of administrations in the past 60 years of NASA's existence. And so NASA issues typically do not make it to those conversations. And so having someone like Secretary Duffy being able to talk about space policy issues in that high profile environment helps elevate the issues, not just with the president and with other members of the cabinet, but also in the media environment, because it's coming up in the news conference, right, that happens after every cabinet meeting. But at the same time, paired with that are some drawbacks. It then turns NASA into one of a series of bullet points that secretary or department head would talk about in those meetings. So although you have a seat at the table, you are then relegated to just that department's sort of fiefdom. And so in the case of moving under Department of Transportation, a serious question is, does that narrow the scope of what NASA works on? NASA's not a transportation agency, right? It's a science agency. Whereas transportation is about getting from point A to point B, NASA is about what are we doing at point B to advance human knowledge of the cosmos. And so, kind of getting lumped in with another agency does, run the risk of curtailing or limiting the aspirations and ambitions of that agency. And then you're fighting within a department's internal politics for that priority to become a priority within that agency's conversations with the White House. And so then there adds this other layer of complexity that NASA is not, the agency as it exists currently is not used to being a part of.
I understand Sean Duffy has also been proposing some changes to the human landing system for the upcoming Artemis missions.
Yeah, and that's kicked off quite a social media firestorm. I think that and some of the conversations about moving NASA under Department of Transportation, which again, just to remind you, requires an act of Congress. This isn't something the administration can just do. And as far as I know, is not an immediate conversation Secretary Duffy is having, but something that happened over the summer. But that, the renomination of potential renomination of Jared Isaacman has created sort of this dust up, and I think really originates from one of the decisions Secretary Duffy has made in the past couple weeks, which is in opening up the Human Landing Systems contract, which is currently awarded to two suppliers, SpaceX for Artemis 3 and 4, and Blue Origin for Artemis 5. Artemis 3 and 4, the SpaceX plan includes utilizing the Starship vehicle and super heavy launch vehicle to get astronauts that last mile from lunar orbit, right, which is the Orion crew capsule, which is going to bring the astronauts to lunar orbit, and getting them that last mile down to the the surface of the moon. So an integral part, right, the linchpin, right, of the Artemis program being a return to the moon program, that return part is all based on the success of the Starship program. And Starship's not been making the progress that has been laid out in Artemis planning documents and in public statements of the agency. Starship has to perform a number of milestones before it's capable. That was the terms that NASA put in the contract for the roughly $3 billion that the U.S. taxpayer is spending on the Starship program to perform these activities. Anyway, so it's come up a couple times, both in a Senate hearing about 2 months ago, and then in some reporting earlier this month in Ars Technica, that there are serious concerns within the policymaking community and the broader space community that SpaceX is not going to be ready for a 2027, a 2028, maybe even stretching as far as 2030 launch window for Artemis 3. And so Secretary Duffy has come in and said, well, our priority, the administration's priority, is getting back to the moon first before the Chinese National Space Administration does. And so we're going to open up that human landing systems contract to other providers. And Blue Origin, again, is one of the providers that was set to provide the lander on Artemis 5. And that is one that the secretary has mentioned is an option. Another one that's come out is Lockheed Martin, who is historically a large aerospace industry organization, provided a lot of hardware for the Apollo program, and over the past 60 years is also interested in bidding on that new award. So who's to say who is going to bring Americans back to the surface of the moon? But that has caused quite a dust up. And I think, again, this mixed with the conversation about Isaacman returning as a nominee, the Department of Transportation, putting NASA under another agency of the government, has caused quite a stir in the space policy community here in DC and around the world.
And all of this against the backdrop of a government shutdown and potentially a 47% budget cut to NASA science. There's just so much going on right now. So thanks for keeping us updated, and I'm sure we'll hear more from you in the future weeks.
Thanks, Sarah.
And now it's time for What's Up with Dr. Bruce Betts, our chief scientist at the Planetary Society. Hey, Bruce.
Hello, Sarah.
This show and next week's show are both about books. And
Ew.
Anytime you get into them, I mean, I don't know, it's part of the privilege of my job that I get early access to these cool space books. But it also means that I read a lot of books. So it does take a lot of time, but then I learn all these awesome things. But in the first half of the conversation, we talked a lot about the ways that solar activity has impacted human history. And a lot of that was ice ages and these large scale things, but we've had a lot of big events in recent solar history. So I wanted to ask you, what are some of the largest moments in recent solar history in the last, say, 150, 200 years?
And you're looking for things that disrupted things on Earth, not just...
Yeah, specifically the space weather that interacted with Earth.
Space weather. Well, the biggie of infamy is the Carrington event, named after a British astronomer, where there was, in you remember it, 1859, there was a big solar flare, which sent some X-rays, and they get here quickly. But also, more significantly, there was an intense CME, or coronal mass ejection. So when the sun belches ginormous amounts of its atmosphere, of its charged particles, headed out more than the usual solar wind, hit Earth 17 hours later and caused all sorts of chaos with catching fire, telegraph machines, auroras seen down in the Caribbean and Hawaii. I mean, so basically this caused an extreme version of all the usual solar wind we're getting hit with, and we see it in a smaller sense since then. But this was the big thing that continues to worry people today, which is it's not going to hurt you, but it can cause power grid failures, satellite damage, communication blackouts, globally. It's a good time. Skipping ahead, you had 1921, the New York Railroad Storm, always a good name, burned out and fires broke out control rooms of the New York Central Railroad, and they blamed space, a likely story. But March 1989 definitely got people's attention in Quebec. Had another big CME came in, it caused chaos and knocked out the Hydro-Quebec power grid, leaving 6 million people without electricity for 9 hours.
God, that's terrifying. I could barely go like 3 hours without power, and then without internet, I shrivel up. So I don't know how people survived.
Anyway, then there were the Halloween storms, which I think I slept through in October and November 2003, but other people did not. A series of solar flares with CMEs, including one of the largest ones ever measured, and knocked out power in parts of Sweden, so sorry. And there's also the danger that you damage satellites, or at least knock them out. And if we have warning of these things, you can do a couple things. You can turn your power grids, if they have enough time, they can put them in a mode where they're not going to get damaged. If astronauts knew, in this case, they buried themselves deeper in the ISS before the CME hit. So anyway, that's a long way of saying there's space weather, and it can affect us, and in our modern world can affect us quite severely if we get one of those big CMEs.
Fingers crossed that doesn't happen. I know Bill Nye had an episode about that in his show, The End is Nigh, where everything gets completely messed up like some kind of giant solar storm. I mean, honestly, like imagine what that would do to our modern society. And hopefully, if it does happen, it's not a long-term effect because everything is so dependent on these systems. It's one more example of why understanding how the sun works and space exploration in general really honestly impacts life on Earth way more than people understand. We love you, son. Please don't bake us alive.
So I'd like to, if it's okay with you, move on to Random Space Fact. Rewind. That's right. Facts are so good, we're visiting them again. Here it comes. If the Earth were the size of a professional soccer ball, then Jupiter would be about the height of a professional soccer goal.
Huh. Well, that's actually a great visual and also terrifying.
Yeah. No, it's impressive. Yeah. You can check out The Size of Space, one of my latest books with the Planetary Society, where I've shamelessly put a picture of my son from many years ago playing soccer, kicking the Earth towards Jupiter. All right, everybody, go out there, look up the night sky, and think about whether you're bigger than a professional soccer ball or if you know anyone who is. I meant goal. Oh, whatever. Thank you and good night.
We've reached the end of this week's episode, but we'll be back next week with more space science and exploration. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review or a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email, planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members from all over this beautiful planet, whose lives have been touched by space exploration. You can join us as we work together to support space science and exploration around the world at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition, and Matt Kaplan hosts our monthly Book Club Edition. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. My name is Sarah Al-Ahmed, the host and producer of Planetary Radio. And until next week, Ad Astra.